Well, we will start by explaining the topic in this slide, which would be motivation. In this section, we will recall the problem of Lincoln Hall, a company that manufactures sleeping bags. The example we are going to review was presented earlier in example 6.11. Our goal is to help Lincoln Hall determine the production levels that maximize their profits. To address this, we will shape the situation using a linear programming problem. And here is what the linear programming model would be. The problem we are going to solve is the following. Wanting to maximize the function of P1, Z2. The objective is subject to certain restrictions. We have restriction A and B. Additionally, we must take into account that Z1 and Z2 must be greater than or equal to 0 to the optimal solution. Well, upon solving the problem, we found that several combinations of Z1 and Z2 can generate a maximum profit of $2,160. These combinations include 24.8, 27.6, 30.4, 33.2, and 36.0. Sensitivity analysis, which in many real-life situations, the values we will use for the coefficients of the constraints and the objective function are simply estimates. The sensitivity analysis will help us understand how the optimal solution will change. If any of these factors vary, this is crucial for decision making and a changing environment. The example in Excel, which we will use in this section to illustrate the ideas discussed, utilizes the Lincoln Hall problem in an Excel spreadsheet. This will allow us to see how linear programming can be applied in practice. 7.1 Production Requirements. Here a table is presented that summarizes the production requirements in terms of labor hours for the different models of sleeping bags. The table shows the requirements of the cutting and assembly departments, as well as the profit per bag. Table 7.2 Solutions in Excel displays the solution we have obtained in Excel. Here we can see the optimal production allocation between the cabin and frontier models, as well as the availability of work hours in the cutting and assembly departments. And well, solver in Excel. We use the solver tool in Excel to solve the simplex LP.